Welcome back, geometry students, to section 5.1. This is part 2 of our video on the mid-segment theorem. In part 1, we kind of proved how the mid-segment theorem works, talked about what it is. Just as a recap, the mid-segment theorem states that if we have a mid-segment here, and a mid-segment being that it connects two midpoints on the triangle, then that mid-segment, this one, will be parallel to the other one, the corresponding side of that triangle, the parallel side. And also we know that DE, that mid-segment, will be the mid-length of that side. So mid-segment in multiple senses connects midpoints, it's half the length, and it's parallel to the corresponding side. So what are the three pairs of parallel segments in triangle DEF? This is example 1. That's where you look at the turkey. All right, so what are the three pairs of parallel segments? First, we got to look at what we got here. As you can see, we have a mid-segment or midpoint there. How you identify a midpoint is seeing these lines here. You have to have those two segments congruent by definition to have that be a midpoint. If it's not, then it's not a midpoint. It's not directly in the middle. So we have a midpoint there. And does it connect to another midpoint? Remember, we have to go from midpoint to midpoint. So if this travels and gets to another midpoint, then that could be considered a mid-segment. And it does. If we look here, we see we have this and this, which signifies another midpoint because these two segments are congruent. So we know we're good there. We have a mid-segment. Let's change color here. Okay, and let's look at midpoint R. We already know that's a midpoint. And we'll see if it travels down to another midpoint. Okay, so here we get to S. We need to analyze this guy. Here we see it's a mid-segment because it has two congruent segments on either side. If it's two congruent segments on either side, then that too is a midpoint. That means that is a mid-segment. Let's change color a third time. And let's travel down to midpoint T. We already know this is a midpoint because we started with it. So we have three mid-segments there. Now, what should we do? What are the three pairs of parallel segments? What are the three pairs of parallel segments? Okay. So now we have to identify which ones are parallel. So let's start with purple since we're already on that color. If we start with purple, I'm going to change to dark purple for its corresponding parallel side. Clearly, we're looking for one of the sides of the triangle, and we're not going to pick this one. I mean, it's pretty obvious that this is not parallel, okay? Same thing with the other side, pretty obvious that it's not parallel. So we're always going to choose the side that's not touching the mid-segment. So the only side that's not touching the mid-segment is this one. So here we have our first pair of parallel sides, or parallel, segments. So we have DE is going to be parallel to, and we can call this TS. And let's make sure we put our little segment hats on. Okay, so there's one. Let's move on to, what color do you want to do? Blue? Okay, sounds good. Let's do blue. Let's move on to blue. And we have RS, okay? Which side is it not touching? And that is DF. Boy, they call that blue. How about no? Let's go to this one. That's better. Okay, so now we have our second one. So 2, we have RS parallel to DF. Okay, and we'll move on to our third one, third and final. How do I know it's the final? Because it's a triangle. There's only 3 sides. Can you believe it? Okay, so we have, it's the last choice available. So clearly we have RT parallel to the side that doesn't touch it, and that is EF. So let's go here. We're going to say RT parallel to, what's it, FE. For all those chemistry folks out there, that's iron. So we have our 3 pairs of parallel segments, and there we go. We're done with example 1. Example 2, a little bit more to example 2. Definitely going to be some problems on your test or quiz or assignments coming up on this type of problem. So we say T, U, and B are midpoints. Okay, so let's go ahead and highlight those 3 points, T, U, and B. Okay, now if you want, you can do this. You can label these lines like this just to show you that they are, in fact, midpoints. okay? All right, now where do we go from here? Well, we're asking to find TU, so let's highlight these just so we kind of organize this in our mind. So we have TU, that's this guy. We have UB, let's go purple for UB. Okay, we're asked to find this guy. And then we'll go, should we go pink? Let's go pink. TB, no, QR. Okay, we're asked to find QR. All right. There we go. We have 3 colors there, and we're asked to find those lengths. Okay, so segment TU. How do we go about identifying how long TU is? Well, the first thing we have to do, since these are all midpoints, we know we have some parallel segments, just how we did in the example above, okay? So what is TU parallel to? Okay, because remember, in our first example that we did in part 1, go ahead and watch part 1. In part 1, we said that if the segments are parallel, then the mid-segment is half the length of the bottom side of that triangle, okay? So let's take a look here. This is clearly the mid-segment. It connects 2 midpoints here and here. So it's going to be half the length of its parallel side of the triangle. Well, where is that? Let's take a look. Well, it's the only side that's not touching it, so that's this side. So these two are parallel to each other. So I'm going to go ahead and designate that with these little carets, as I call them. Arrows, as most people say, but I like saying carets. Okay, so we know that TU, and you don't have to write this down, I'm just showing you visually, is parallel to RS. Now, we know one of those lengths. We know that RS equals 40. What else do we know? We know that TU equals 1/2 of RS, because that was the definition of the midsegment. Okay, look up here. The midsegment is half of the corresponding parallel side. Okay, so what we're going to do here is we're going to just plug in what we know. We know RS is 40, so we're going to say TU equals 1/2 of 40. So we get TU equals 20. So we have our first answer. This is 20 units long. And I guess you should write units. It doesn't give a units, feet, centimeters, anything like that, so we're just going to call it 20 units. All right, purple. Let's move on to purple. What's the parallel side to it? Well, the parallel side is this guy. Okay, it's the side that's not touching it. Sorry, I messed up there. I'll fix it. There you go. Now let's go and put the little carets on there. Arrows, whatever. Okay, I don't want to do that though, because I want to have it different. So you don't want to put 2 carets. If this guy's 2 carets, you don't want to use 2 carets on the other guy, because then you're kind of falsely claiming that they're parallel. So now we know it's the same process. We know QS is 50. So we know that UB equals 1/2 of QS. So we know UB equals 1/2 of 50. So UB is going to equal 25. So we have UB equals 25, and we're almost there. 25 units. All right, last one. We're looking for QR. This time we're looking for the long length. We're given the mid segment. Okay, so let's identify what's it's parallel to. Okay, we got this guy. Kind of use orange, whatever. So we used orange, and we're going to go ahead and go in reverse. So we know that a couple different ways we can do this. We can say TB equals 1/2 of, what is that, QR. Okay, and we can say TB is 30 equals 1/2, and then we're going to solve for QR. That's one way to do this. Okay, some people don't like solving with the halves there, but it's not hard. You just multiply it by the reciprocal, which is 2, or 2 over 1. I'll put 2 over 1. That cancels out with the 1/2 on the right, leaving us QR. That's what we're looking for. And we get QR equals 1/2 times, or 2 times 30, and we get 60. Another way to do this is using our second equation here, which is our midsegment times 2 equals AB. So we can just go like this. We could go TB times 2 equals QR. And then again, same thing. We're going to erase this TB, and we're going to write 30. And we get the same thing. We get QR equals 60 units. So there you have it. That's how you solve these types of problems. I hope you enjoyed this video. Make sure you stay tuned for section 5.2. Hope to see you there.